Hello. So today we're going to look at the Cartesian equation of a plane. So let's just scroll over to the right here, and I have the Cartesian equation form of a plane written here. So it's given by ax plus by plus cz plus d, and that equals 0. So here are coefficients of our variables x, y, and z make up the normal to our plane. So if we have our plane, this is our plane. Sometimes I use pi to denote a plane. This is our plane. And n is perpendicular to our plane. It's normal. All right, so we're going to use this form and answer a few questions. So we have a plane defined by this equation, 2x minus y plus 3z equals 0. What is a normal to the plane? Does the plane pass through the origin? Explain why or why not. And write the coordinates, I think it should be plural, coordinates of 2 points on this plane. Interesting. Okay. First question. The normal. The normal is given by the coefficients of the variables. So 2, -1, and 3. Okay, easy. B, does the plane pass through the origin? I don't know, let's see. Let's try and plug the origin into our plane. So our origin 0, 0, 0. Let's plug it in. So we'll plug it into the left-hand side. See if it equals the right. So 2 times 0 minus 0 plus 3 times 0 equals 0, which equals the right-hand side. So yes. Yes. Okay. C, write the coordinates of 2 points on this plane. Well, the origin. Let's see, what's another point? So we need to find values for x, y, and z that satisfy this equation. So let's try x equals 1, y equals 1, and then we got to figure out our z. Let's do this. So we have 2 minus 1 plus 3z equals 0. So that's 1 plus 3z equals 0. So z equals -1/3. So therefore, 0, 0, 0, and 1, 1, and -3 are 2 points on this plane. Are 2 points on the plane. Good. All right, next question. Determine the Cartesian equation of the plane that contains the points A, B, and C. All right. So we have 3 points, A, B, and C. So for the Cartesian equation of a plane, we need a normal. How can we find a normal given 3 points? Well, we can create 2 vectors. If we take their cross product, we're going to get a vector that's perpendicular to those first 2 vectors, and that will be our normal. Right. So let's find our 2 vectors. Our first vector is AB. Let's find that one. So B minus A is a 1, 1, -1, -3, -1, 2. What does that equal? That's 1 minus 3 is -2. 1 minus -1 is 2. Okay. -1 minus 2 is -3. Okay. And our second vector is AC. AC. C minus A. Point C is 0, 4, 1 minus A3, -2. So our vector is 0 minus 3, -3. 4 minus -1, that's 5. 1 minus 2 is -1. Okay. Okay, so we have two vectors. Now we need to take their cross product to get the normal. So let's do that. So A, B crossed with A, C. Now we know how to do that. We make a box of numbers. Put our two vectors in as rows. And we then plug it into our formula for the cross product. So I, the coefficient of I, is from this second box here. So -2 minus -15, so plus 15, minus j, coefficient of j is -2 times -1, minus -3 times -3, plus k, and the coefficient of k is the second box of numbers, -2 times 5. Just move things over a little bit. Sorry, -2 times 5 is -10, minus -3 times 2 is 6, -6. All right, so coefficient of I is 13. Coefficient of j is actually 7, negative -7, so plus 7. Coefficient of k is -4. So we can write this in coordinate form as well. That's our normal. Okay, so since our plane is going to contain the points A, B, and C, our normal is a cross product of the vectors A, B, and AC. So now let's put it all together, at least a start. So we have, perhaps we shouldn't use A, B, and C. All right, so our plane has the following form: 13x plus 7y minus 4z plus d equals 0. So we need to figure out this d, or this intercept. So we can do that by taking one of our points, A, B, or C, and plugging it in to our equation. Let's use C. I'm going to take the point C and plug it in. All right, and I chose that because we have 0 as one of the values of one of the coordinates. So we have 13 times 0 plus 7 times 4 minus 4 times 1 plus d, and this all equals 0. So we have 0 plus 28 minus 4 plus d equals 0. So we have 24 plus d equals 0, or d equals -24. So therefore, our plane is 13x plus 7y minus 4z minus 24 equals 0 in Cartesian form. Good. So that's the Cartesian equation form of our plane: 13x plus 7y minus 4z minus 24, and that equals 0. So what did we have to do? We had to take the cross product of two vectors to get our normal to our plane. And then all we have to do is plug into our formula, our Cartesian form of the equation of a plane, and finally plug in a point on that plane to get our constant d. Good, so that brings us to the end of our session. If you have any questions, send us an email at info@raisemymarks.com or give us a call, day or evening, and we'll be happy to answer your questions. Thank you for watching.